Yes, hello everybody. My name is Chris Overcash, and I'm the Deputy Director of Coastal Resilience for EA Engineering, Science, and Technology. And the next project we'd like to discuss with you is in regards to planning for coastal resilience in Northern Chesapeake Bay, and we'll be dialing into environmental considerations for that project. So just as a quick background, this planning study was completed in 2019 as a joint land use study for the Office of Economic Adjustment, Department of Defense, focused on a few different areas, Aberdeen Proving Grounds in Maryland, as well as the surrounding counties. In the framework, as you can see on the left, was dictated by certain steps, and I'll be going through those as we quickly discuss the project. So the first item is project scope identification. And in the case of this project, we were focused on a lot of different perspectives. And so as it applies to the context of our discussion at the conference, part of that were environmentally sensitive areas, including landfills, state designated hazardous sites, as well as surplus sites, brownfields, as well as military ranges, which involved unexploded ordnance issues. And you can see the rest of the encompassing items that the scope addressed, including other environmental areas, as well as infrastructure impacts created by the particular project for coastal resilience. So the next item for the project was to identify climate impacts. And this would be similar to any climate resilience project in that you have to identify the potential impacts. And for us, we were looking at mostly at coastal impacts. And you can see the main three components here. So it's not only sea level rise, but potential impacts from precipitation, as well as associated storm surge with large events. So the first item to realize in a project like this is that there are many different data sets. So for our particular site in Northern Maryland, there were several items that we looked at. And basically, you can see here, sea level rise projections from 2018 were directed at a worst case scenario of about 7 feet for the high range. We also had storm surge indicated and precipitation for the area. So once that is identified, the next step is to identify climate vulnerabilities. And for this project, we looked basically at a GIS-based model tied into those sea level rise components. So you can see here, this is a map of Aberdeen Proving Grounds, which is one of the lowest lying areas in Chesapeake Bay. So we could expect significant impacts to the end of the century. You can see here just an example of some of the visualizations of our project, current conditions at Aberdeen Proving Grounds. And then as we move through the century, you can see this is 2100 mid scenario, shows a 2.3 foot increase, but also if you add the major flood stage to that, it inundates further areas. And then worst case scenario, as you get closer to 2100, you can see significant flooding components on this portion of Aberdeen Proving Grounds. Just as a comparison, the other areas within the county had more elevation. So this is actually Havre de Grace, Maryland. You can see because there is significant topographic elevation in the town, you can see it is impacted to 2050 and 2100, but it's mostly contained or in the coastal zone for that town. So once you've identified the climate vulnerabilities and they're specifically identified, you moved to the strategies and measure of options that could be brought to bear to protect coastal areas. So when it comes to that, you're talking about a framework of three different ways to proceed. Accommodate would be to alter existing structures to be able to withstand those climate impacts, in this case, sea level rise. Protect would be using heavy or hard engineering solutions to protect areas, including areas with environmental contamination. And third, manage retreat, relocation of structures in areas from those particular zones. Now that becomes problematic if you're talking about managed retreat in the context of contaminated sites, because obviously you would have to remediate those sites or they would still be impacted in those future conditions. So within our report, we identified the potential solutions for these various impacts, and they were defined, as you can see here, in three different areas, three different ways to provide that resilience: natural, non-structural, and then structural. Just to touch on what some of these are in more detail, structural or nature-based measures to protect these areas include reestablishing or increasing dunes or beaches in an area. Vegetated features also provide extra protection, such as wave attenuation. So you're talking about increase of coastal marshes, submerged aquatic vegetation. We also looked at potential restoration of barrier islands that can also obviously dissipate wave energy. And then another key item, maritime forests and shrub communities also provide some of that extra resilience. So, this is one of the first things that we looked at for potential solutions in these areas of impact in Northern Chesapeake Bay, the nature-based measures. Next, there are all obviously non-structural measures you can proceed with, such as changing floodplain policy and management. This can have significant benefits later on in the century if you start implementing them now, so that people start moving out of those danger areas. In the case of contaminated sites, that would also be the case. Gives you more time in planning to remove the constituents of concern from those areas. Floodproofing and impact reduction is also a solution, and obviously relocation is possible in certain situations. Then finally, structural measures. So these are items that folks would probably be deferred to when you think about solutions to coastal flooding. So hard structures like levees, even storm surge barriers, seawalls, and revetments that can provide that shore armoring in situations where a specific area has to be protected. These are sort of a last resort in particular areas. So once you have possible measures identified, the next is to then use those possible measures and adapt them to a specific plan for an area. And some of the keys there, as we talked about before, obviously timing to these coastal impacts is going to be based on how quickly sea level rise occurs. And it's also based on criticality of areas, such as if you have unexploded ordnance in an area, how critical is it to move forward with that quickly. So again, timelines on when to execute these measures are based on criticality, your specific identified strategies and measures, and then looking at adaptive design considerations, such as seawalls can be designed to be added on later. So to make sure that your base design for a seawall that you might construct just to 1 foot by 2050 could be raised to 3 feet, say, by 2100. And also, it's key to understand the study horizon. What is your target study or your target date for completion? Another important consideration is that there are many grants available for this type of work. An example was for this project, we had a follow-on project with the city of Aberdeen, which is adjacent to the base, to complete a full assessment of climate adaptation. And we actually looked at using dredged material to provide that coastal resilience and protect that town and some of the environmentally sensitive areas there. So again, just to reiterate, there are many grant platforms available for this this type of work. And this is just a list of some that were available in the Chesapeake region and some on the national basis as well. And we'd be willing to talk with you about potential funding mechanisms if some of these thoughts may help with your particular situation. So thank you very much for your time, and enjoy the rest of the conference.